Hi YouTube, Unkert here. In this video, I want to talk about Lambda expressions in Python. So Lambda expressions are anonymous functions that we can use once and then just get rid of, okay? And to demonstrate this, I'm going to create a list. I'm going to say my list equals 1, 2, 3, 4, 5, okay? And let's say I want to square my list. So I could create a new list, my squared list. And I could say that equals, we'll use the list function. And then we're going to use this function called map. Okay, and map is a function that basically it will allow a function to iterate through each item in an iterable. In this case, we're going to use the list. So I'm going to say lambda. Okay, then I'll do for each list item, I'll take the list item and I will square it in my list. Okay, so this is the kind of syntax that we'll get. And then we could, of course, print my squared list. Okay. All right, so if I run this, we see we get the list item squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Okay. Now we could also use a similar method, or we could also do this with a list comprehension method. And so let me demonstrate with a cubed list. So I could say my cubed list equals, and we'll use list comprehension. We'll say, we'll take each item in the list and we'll cube it for each item in my list. Okay. And then what we could do is we could print my cubed list. Okay, and if we run this program, we see that the bottom list is each of the original values cubed, so that works fine. So we can do list comprehension as well, but in a moment, coming near the end of the video, I'll show you how lambdas really are quite useful, especially when we're sorting certain things like dictionaries. One other area where we could use lambdas is in a competitive coding situation. So for instance, in competitive coding, a lot of times like you'll have a test case, and then as you loop through each of the test cases, they'll give you a bunch of space separated integers. So for instance, one way you might take that is you might say my string equals input, and then you might split that, and we could say, my string list, something like this. Okay. And we could split them based off the spaces, and you'd have random numbers coming in, random integers separated by spaces, and that would give you an array that was something like 2, 4, 5, 6, and 7. But these would all be of type string. Okay, and we could demonstrate that. I could say for I in range the length of my string list. Let's print my string list at index I, and let's actually print the type of my string list. Okay, so we could do that, and if we run this and we go in, we enter in a few different values. I'm just going to make up some integers here, and you'll see here it says, each one of these is a class of str for string. Okay. So if we had this in a competitive coding situation, we'd want to change these into integers. Now we could, make each one an integer and then append it to a list. But we can either do this with a lambda function, or we could do it with list comprehension. And the lambda function way, we could say something like my int list, and we could say equals a list, and we'd use this map function. And then we'd say lambda item, and for each item in the list, we'd make it an integer, okay? And then we would do this for my string list, okay? And now if we go through this, so if we say for I in range the length of my int list, let's print the type of my int list at index I. Okay, so if we do this and run it, We enter in some integers, so 2, 3, 4, 1, 5, just random numbers here. And we see that they're all class of integer. That is one way we could do it, okay? Now, another way we could do it is we could say, let's say my int2 list, something like this. We could say we're going to make each item an integer for each item in my string list. And then we could go through and we could say for I in, just to demonstrate that these are all integers, in the length of my int2 list, we're going to print the type of my int2 list at index I. Okay, so we'll just demonstrate that these are all integers now. Okay, so we go through, let's enter in some numbers, 2, 4, 5, 1, 9, 8. And we see we get class of integer for all of these, okay? So there's two different ways you can do it. The list comprehension way, based on my experience, is a little faster. So just letting you know that. You could do, of course, the Lambda way. So just to demonstrate that, let's do a start time equals time dot performance counter. And we got to import time. You'll see my IDE did that automatically for me. And then we'll say the end time equals time dot performance counter. And then we'll do a start to time equals time dot performance counter. And then end to time equals time dot performance counter. And then we'll have execution time 1, that's going to equal end time minus start time. And then execution time 2 is going to equal end 2 time minus start 2 time. Okay, and then let's just print execution time 1 and then print execution time 2. Okay. Again, this isn't the most scientific way to do it, but just to demonstrate. Okay, so let's enter in some integers here. So let's do 2, 5, 7, 3, 4, 5. Okay, and actually, whoa. No, actually, not whoa. So, yeah, I saw 5 and 6, but then you look, it's like times 10 to the negative 5. This one's times 10 to the negative 6. So the times 10 to the negative 6, the second method, the second execution time is an order of 10 smaller, okay? So, if we ran this maybe with a few more numbers, let's try it again. Let's 2, 4, 5, 6, 8, 1, 2. I'm just making up random numbers here. 3, 2, 7, 8, 9, 4, 1. I don't know, whatever. And so again, we get 6 point something times 10 to the negative 5. Here's 8.5 times 10 to the negative 6. So, it's an order of magnitude smaller in time using the list comprehension method. And I'm sure someone watching will come along and say, hey, there's even a faster method. Do this. So please comment in the comments if you want to demonstrate a faster method. Back to lambdas, though. So what I want to do now is I'm going to get rid of this stuff and show you another use of lambdas. So I'm going to say my ages dictionary. So my ages dict, let's just call it that. And we'll give a bunch of names here and a bunch of ages. So Sarah's 49. Tim is 46. Aaron is 47. Will is 17. Joe, he has a mental age of 11, one of my best buddies. Ben, his age is 46. Okay, so let's say we wanted to sort this ages dictionary based off of the values, the ages, all right? Well, what I can do is I can say my sorted dictionary, so my sorted dict equals a dictionary. We want to make this a dictionary, and then we're going to use the sorted function, and we're going to use my ages dict dot items, if I can spell, dot items. There we go. Dot items. Okay, and I'm going to say the key equals a lambda function. And we're going to say for each item, we'll call it X. We're going to sort based off of the value, which would be at index 1 versus the key, which would be at index 0. Okay, and now what I can do is I can print my sorted dictionary, and let's run that. And you'll see we start with Joe, he's 11, Will 17, Tim 46, Ben 46, Aaron 47, and Sarah 49. Okay, so it has sorted the list based off the ages. Okay, pretty cool. Anyways, I think that's it for this video. If you liked the video, please give it a like and subscribe to the channel. Thanks for watching.